How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss how to solve quadratic inequalities. But before anything else, hit the subscribe button and notification bell for you to be updated of the school clear math videos just like this. Hello math learners, welcome to another session here in Math Learning with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for Quarter 1, Week 5 of the Grade 9 Mathematics, which is all about how to solve quadratic inequalities. On our previous videos, we have already discussed how to illustrate and define quadratic inequalities. For a quick review, it means that quadratic inequalities are those inequalities, meaning it uses the symbols greater than, less than, greater than or equal to, less than or equal to, and not equal, and the whole expression is in the highest degree of 2 or in the second degree. Now, the question is, how do we solve quadratic inequalities? Before talking about solving quadratic inequalities, first, there are two things that you need to have an idea or a prior knowledge for you to be good in this topic. The first one is that you have an idea how to solve inequalities in the linear expression. And the second one is you know how to solve quadratic equations. But if you have forgotten the techniques on how to solve inequality and how to solve quadratic equations, then I will teach you in this discussion for a quick review. Now, let's talk first about linear equation. Of course, linear equation is an equation in the first degree, right? So this is an example of a linear equation. We have 2x plus 1 is equal to 3. Example, okay? When we solve this kind of equation, what we do is we isolate the value of x, right? So we transpose our 1, so that is 3 minus 1, then we copy our 2x. And then, we simplify the equation, giving us 2. And for us to eliminate the coefficient of 2, here in x, we just divide the whole equation by 2. So this will be cancelled and x is equal to 1. Therefore, to satisfy this equation, the value of your x should be and must be equal to 1. Now, how about linear inequality? We have 2x plus 5 is greater than, let's say, 11. Okay. So, how do we solve this linear inequality? The same concept, okay, in solving our linear equation, what we do is we transpose our constant term to the other side, so giving us 11 minus 5. And then it gives us 2x, okay? So this becomes 6. We divide the whole equation by 2 to isolate our given value of x. So 6 divided by 2 is 3. So x is greater than 3. So this is not yet the final answer, but we need to establish our final answer in this matter. How do we do that? What are the numbers that are greater than 3? So those are 4, 5, 6, 7, so on and so forth. So how do we write our answer? The first thing you could consider is by the use of bracket and parentheses. We use bracket, this one, okay? If your symbol is greater than or equal to and less than or equal to, okay? We use parentheses if the given is greater than, less than, or not equal. Okay? But since this is x is greater than 3, therefore we will use parentheses. Okay. Since we start from 3, but 3 is not part of our answer, we can just put 3 and then 4, 5, 6, 7, 8, 9, 10. That is infinity. So that is 3 positive infinity. And that will be your final answer. So therefore, your solution set for x is greater than 3 is this one. Now, the question is there any other way to write our answer? There is, my dear math learners. The other one is by just writing that since this is x is greater than 3, then we can just put the set of real numbers such as x is greater than 3. So, if your answer is like this or like this, then you are correct. So, that is how you solve linear inequality. Now, the question is, how do we solve quadratic equations? Now, in solving quadratic equations, remember that there are 4 different methods in solving quadratic equations. The first one is the use of extracting square roots. That is if you have no middle term or linear term. The second one is through the use of factoring, which is one of the convenient ways to solve quadratic equation. And the third one is by the use of completing the square. And finally, the safest method is the quadratic formula by the use of the formula x is equal to negative b plus minus square root of b squared minus 4ac all over 2a. So now, let us consider one example for quadratic inequality. Okay, math learners, we have here an example. X squared plus x is greater than 12. The question is, how do we solve this one? The first thing you should do is remember that this is quadratic inequality, right? Okay. The first thing you should do is you change the inequality into an equation. Okay? So this will become x squared plus x is equal to 12. Now, you apply what you have learned in solving quadratic equations. So, I want to use factoring. So, therefore, I will transpose my 12 and make it in the standard form. Okay? So, that becomes x squared plus x minus 12 is equal to 0. Then, by the use of factoring, I will make two quantities. Okay? So, I will factor first x squared, and that is x and x. And I will factor negative 12 such that if I add them, the final answer is positive 1. Okay, because this is x. So, therefore, there is a coefficient of 1. So, what are the factors of 12, negative 12? That is positive and negative 4 and 3. Okay, so positive 4 and negative 3. Now, the question is, can I disarrange or can I put positive 4 here and negative 3 there? Yes, you can do so. But your 4 must be positive and your 3 must be negative in this scenario. Why? Because if you multiply them, that goes negative 12. And if you add them, that goes positive 1. Easy, right? Okay. Now, if you are in this part of your solution, what you need to do is to solve them separately to get the value of your x. So, that is x plus 4 and that is x minus 3 is equal to 0. Okay. So, by using of transposition property, this becomes negative 4. By the use of transposition property, this will become positive 3. Therefore, this means that the boundary of my answer is in 3 and negative 4. Now, is this the answer for my problem here? X squared plus x is greater than 12? Okay. The answer for that is no. Why? Because we are talking about inequality. And if it is inequality, then your answer is most likely to be a solution set. Meaning, there are series of numbers that can satisfy this given. Now, let us try to check so that you know what I am talking about and you can be aware why this 2 is not the real answer. Okay, so I'll try to change x here as 3. So, that is 3 squared plus 3 is greater than 12. Okay, so this will become 9 plus 3 is greater than 12. And 12, 9 plus 3 is 12 is greater than 12. 12 is greater than 12? Alright, that's not correct, right? So therefore, these answers are not your final answers. Yet, these are your boundaries for your final answer. What does this mean? Okay, let me show you what quadratic inequality means. By having this one, let's consider a number line. Okay, so this is wrong, right? Okay. So, that is positive 3. So, if this is 0, this is 1, 2, 3, 4. Okay, this is positive 3. And then we have here 1, 2, 3, 4, 5, 6. This is negative 4. Okay. So, your answer is here. Okay. Now, as you can see, there are 3 regions for you to consider your answers. This is the left region, the middle region, and the right region. Okay. So, how do we know the final answer for this given problem, Sir Ash? What we need to do is we will use the 3-point test. What do you mean by 3-point test? We will find numbers from the left region, from the middle region, and from the right region to test whether those numbers are satisfiable for this given inequality. Okay, so let's try first our left region. So since this is negative 4, what are numbers for on the left side of negative 4? So that is, yes, the closest is negative 5. Okay, so let's try x is equal to negative 5. That is for our left region. And then we have x is equal to 0 for our middle region. Okay, so in the middle we can see 0 here. And for the right region, we have x is equal to 4. Because 4 is after 3, positive 3. Okay. Now, if you want to ask me, Sir Ash, am I the one to put values for this left, right, and middle values? Yes, you are the one who will be choosing what number you want to use for you to test if ever this given inequality can satisfy your solution. Okay. Okay, math learners, let us now test our left point, middle point, and our right point if these points can satisfy our given quadratic inequality. So, our quadratic inequality is x squared plus x is greater than 12. Now, let's try our negative 5. So, that is negative 5 squared plus negative 5 is greater than 12. Negative 5 squared is positive 25. Positive times negative, that will become minus 5. And then, we have greater than 12. 25 minus 5 is 20. 20 is greater than 12. Now, the question is this correct? 20 is greater than 12. Yes, that is correct. That is true. So, therefore, we can say that our left region is part of our solution. So, if this is your left region, then it is part of our solution. All the numbers in the left region can satisfy this given quadratic inequality. Now, the question is, am I true with my solution? Not yet, because we need to test all 3 regions for you to have a complete answer. Now, let's go to the second point, which is the middle point. X is equal to 0. So, we have 0 squared from here, okay? 0 squared plus 0 is greater than 12. 0 squared is 0 plus 0 is greater than 12. 0 is greater than 12. Is this correct? No, that is not correct. And that is false. Therefore, we can say that the middle part or the middle region of our given is not a part of our solution. Now, let us go to our right region. So, after the number 3, so we use positive 4. So, let us try 4 squared plus 4 is greater than 12. 4 squared is 16 plus 4 is greater than 12. 16 plus 4 is 20 is greater than 12. Is this correct? Yes, 20 is greater than 12 and that is true. Therefore, the right region or the numbers in the right region is also part of our solution set. Now, how do we write our final answer? That is x such that, or the solution set of x such that x is, okay, this is the one, right? So, those number that is less than negative 4. X is less than negative 4 or x is greater than positive 3. I say less than because we are talking about numbers that are less than negative 4. And I say greater than 3 because we are talking about numbers that are greater than positive 3. Now, what are the ways in order to show this answer? You can also write your solution in this manner, or you can also use this kind of solution. So that is x is less than negative 4 union of x is greater than 3. Okay. So we use the word union. Remember, in the lesson of set theory, the meaning of or means that either this one or this one is acceptable. Okay? So that is how you solve quadratic inequality. Now, let us consider another example. Okay, math learners, for our next example, we have 7x squared minus 28 is less than or equal to 0. Question is, how do we solve this quadratic inequality? So, it's very simple, the same concept. We will change our inequality symbol into an equal sign. Okay? And then you solve for the value of x. So, remember that this is factorable by 7. So, I can divide the whole equation by 7. So, this gives me x squared minus 4 is equal to 0. So, right now, I have x squared minus 4 is equal to 0. In this example, this is an example where we don't have any b, right? Okay. So, I could use extracting square root. So, that is x squared is equal to positive 4. Okay. And in order for me to get the value of x, I square root both sides of the equation. This will be cancelled. So, x is plus, minus, or positive negative 2. Meaning that the value of my x is positive 2 or negative 2. Question is this my final answer? Not yet. For you to consider, you need to make your number line. This is your 0. 1, 2, 3, 4. This is your positive 2. 1, 2, 3, 4. This is your negative 2. Okay? And we put our points here. Now, since this is a greater than or equal, less than or equal, then I will be making a dark dot. Now, about the dot that you will be making, if the symbol is greater than or equal, you will use a hollow dot. Not 0, ha? Okay, this is a hollow dot. And if you are having the symbols greater than or equal or less than or equal, then you will be making the dark dot. Okay, so now I have the left, the middle, and the right region. So for my left, I will choose numbers that are less than negative 2. I think that is negative 3. Okay. So I will use negative 3. Here I will use 0. Okay, 0. And here I will use positive 3. Okay. So let us test our values. So we have x is equal to negative 3, x is equal to 0, and x is equal to positive 3. Okay. And the given is 7x squared minus 28 is less than or equal to 0. Okay. So now, this means that I will first check for my left region. So that is 7 negative 3 squared minus 28 is less than or equal to 0. So that is 7. Negative 3 squared is 9. Okay. Minus 28 is less than or equal to 0. 7 times 9, that is 63. Minus 28 is less than to 0. Okay. And 63 minus 28, that will give me 35. Okay, 35. Because 35 plus 28, that is 63. Okay? So, is 35 less than 0? Okay, that is false. So, therefore, the left side of our answer is not part of our solution. Okay, now let's consider 0. We have 7 times 0 squared minus 28 is less than or equal to 0. So 0 squared, that is 7 times 0, minus 28 is less than or equal to 0. So 7 times 0, that is 0, minus 28 is less than or equal to 0. 0 minus 28, that is negative 28, is less than or equal to 0. Now, the question is negative 28 less than or equal to 0? Yes, it is. So that is true. Therefore, all the answers in our middle is part of our solution. Now, for our final, we have positive 3. So we have 7 times 3 squared minus 28 is less than or equal to 0. So this becomes 9 minus 28 is less than or equal to 0. This will become 63. The same concept here. Okay. And 63 minus 28 is 35. Okay. And that is equal to 0. So 35 is less than or equal to 0. That is also false. Therefore, our correct and final answer for this here, for this given problem, is that all the numbers between negative 2 and positive 2. So how do we write that one? So what you will do here is that for the final answer, you will express it as the solution set of x such that the x that is in the middle is greater than negative 2, but it is less than positive 2. So, and this is the final answer for this given quadratic inequality. Easy, right? Now, this is the time that I will challenge you whether you have understood our topic for today, and here it is. Okay, math learners, I hope you have understood our topic about quadratic inequality, specifically solving quadratic inequality. I know this may be tedious for you, but with constant practice, just remember that first thing you should do is you solve it with the use of the methods in solving quadratic equations, and then basically you make a number line and you do the 3-point test for you to know whether the left region, the middle region, or the right region will satisfy your solution. But if you still have misunderstanding or confusions about this topic, do not forget to put your questions in our comment section below. Okay, now I just like to shout out Floyd Jane Poligrates, and I hope you are taking good care of yourself there. And my dear math learners, this is still your free access math teacher Ash, and always remember, it is fun to learn mathematics if we are together learning. Thank you so much, God bless, and thank you for subscribing and clicking that notification bell for you to be updated of our math videos. God bless. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.